A very good morning, students. In today's class, we'll study about a case study on sugar industry. Case study: Rajshri Sugars Chemicals Limited, Theni. The synopsis of this presentation is we'll study about the sugar industry and Rajshri Sugar Chemicals Limited and sugar processing, boiler house, powerhouse, distillery unit, biocomposting process, and effluent treatment plant present in that industry. Sugar industries. So, as we all know, sugar is an agro-based industry, and sugarcane is the raw material used. And from that, they are producing power, fiber, alcohol, and a biocompost. So, from this industry, there is no waste coming out of this industry. Details about Rashri Sugars. So it is a public limited company. So it has a capacity of 2,500 tons per day, and it recovers around 10.32% recovery, and they are producing 12 million liters of alcohol per year, and their capacity is 45 kiloliters per day, and they have an installed capacity of boilers or cogeneration plant of 12 megawatt, and they have a surplus power supply to the grid around 3 to 4 megawatt. So they produce biofertilizer, biofungicides, biopesticides, biocontrol agents, etc. So around 10,000 tons per annum of organic manure is produced in this industry, and around 75 tons per annum of bioproducts production unit is there in this industry, and there is a tissue culture lab production capacity of 0.5 million seedlings per annum. So then we'll study about the sugar processing. So initially the raw material is transported to the industry and it is unloaded. So milling process is done, primary juice heating, juice sulfitation, secondary juice heating, clarification, evaporation, syrup sulfitation, crystallization, separation of sugar and mother liquor, sugar drying and grading, storing and dispatching of final molasses. So this is the flow diagram of the overall plant, sugar plant. So first initially the raw materials transported from the outside and it is weighed and prepared. A cane milling or crushing of sugar cane is present. Then the juice extracted is sent to the clarification and the addition of sulfur and sulfatation process, syrup boiling, centrifugation, factory raw sugar is being dispatched. So the waste from the crushing mill is the bagasse or the solid waste generated in a sugar industry, so which is sent as the feed for boilers, and in turn it produces steam, and from the steam is used to run the turbines and the power is being generated. So it is utilized in the industry, as well as it is also the excess or the surplus power generation is being connected to grid. So after that the clarification unit, so press mud is produced. So press mud from the boilers is also sent to the biocomposting. So the wastewater generated from sugar industry is the spent wash and the molasses. So the molasses is sent as the raw material for the distillery unit. So from that fermentation, so yeast is added, alcohol is produced, and from that wastewater, spent wash, and waste material from boilers is press mud. So both press mud as well as the spent wash is laid in a land and it is turned around 3 months, and the biocompost is produced as well as the alcohol is produced. So unloading and milling process, so it takes place around in shell and tube exchanger, so 50 to 70 degrees Celsius at a pH of 5 to 5.5. The sulfitation process is the addition of lime and sulfur dioxide. So the pH of the lime is 8.3. So after the addition of sulfur dioxide, the pH will be 7. The secondary juice heating is also taking place in shell and tube heat exchanger. Then the process is sent to a clarification tank, so where the mud, all other inert materials are removed. So after that, so the press mud, after extracting completely the juice, the press mud is produced. So and again it is sent to the evaporator, in which at a temperature of 110 degrees Celsius to 115 degrees Celsius, the water is being evaporated, and it is sent to the boiler feed. And syrup sulfitation, the sulfited syrup pH is maintained at a pH of 4.8 to 5.2. The next process is sugar crystallization. So it is done in centrifugation process. So pan boiling section. So seeding of 3 to 5 microns, and separation of sugar according to their grades is done in a centrifugal separator. Sugar drying and sugar grading. So hot air drying, air cooling, sugar grader, and bagging and storing is done in the industry. So this is the overall process of sugar industry. The boiler house. The various accessories involved are furnace, superheater, boiler tank, air preheater, economizer, and demineralization plant. The heated water is sent to the economizer boiler steam at a temperature of 380 to 480 degrees Celsius, and the flue gas is sent to the inlet of economizer to preheat the bagasse, and so that the remaining moisture content in the bagasse is removed now, so that the outlet temperature of the economizer is 245 degrees Celsius, and air heater output of temperature is 180 degrees Celsius. Air preheater outlet temperature of 130 degrees Celsius. Air required is 5.76 kg per kg of bagasse. So this is the preheating. Air preheater is used to remove the moisture content present in the bagasse. So feed water parameters. Electrical conductivity at a temperature of 20 degrees Celsius, it is 0.2. Carbon dioxide is nil. Hardness is 0.2 to the maximum, and silicon oxide is 0.2, and pH is neutral. So this is the boiler efficiency. So enthalpy of feed water, superheating temperature, calorific value of gross calorific value of bagasse is 9627 kilojoules per kg, and bagasse flow rate is 805.5 tons. So from that, the efficiency obtained by the boilers is around 64.19%. So back pressure turbine capacity is 6 megawatt. Back pressure turbine 3 megawatt are present. So extraction cum condensing turbine is 6 megawatt, and the surplus energy produced in the industry is 3 to 4 megawatt surplus power. So this is the specification of the turbine. Turbine efficiency is around 97.76%. This is the daily cane bagasse generation and steam generation of Rajshri sugars. So from the figure we can see, like the cane crushed is increased, and the bagasse produced is also used for the production of steam in the boilers. Daily steam and power generation. So power generation increases as the rate of bagasse production increases. So this is the comparison of specific heat consumption. Next we'll study the distillery unit. The plant capacity is 45 kiloliters. The rectified spirit is 45 kiloliters. Extra neutral alcohol is 10 kiloliters, and anhydrous alcohol production is 45 kiloliters. So these are the technical details of the fermenter. The fermenter capacity is 350 meter cube per 3.5 lakhs liters. So the effective working volume is only 250 meter cube, that is 2.5 lakhs liters. The pH is 4.5 to 4.8. So the molasses, the pH of the molasses is acidic. So the fermented temperature is 30 to 35 degrees Celsius. Alcohol concentration is 7 to 8%. The total yeast population is 500 to 600 million cubic unit. Nutrient dosages of urea is 5 kg per hour and diammonium phosphate of 3 kg per hour is being added daily, and dissolved solid concentration of 11 to 30% is present in the fermenter. So other technical details are the spent wash generation is 8 liters per liter of alcohol production. Yeast sludge generation is 30 to 40 million tons with 60% moisture per year. So along this is the milling of yeast culture. So addition of 25,000 liters of molasses every 6 hours. After 48 hours, add molasses to increase the concentration to 22 to 35 tricks. So these are the different grades of alcohol. Fermentation is an exothermic reaction heat. During fermentation process, yeast cells convert sugar into alcohol. The material settled to at the bottom of hydrocyclone is fed to the bottom of the analyzer column to strip the alcohol present in it. The overflow from the hydrocyclone is fed to the yeast separators to separate the yeast and de-yeast the wash. So this is the process of distillation. Distillation, preheating of 85 to 90 degrees Celsius. Preheater, small quantity of vapor with impure gases is separated from top of the degasifying column and fed to the degasify condenser. The steam is applied directly to the bottom 92 to 95 degrees Celsius. The enriched spirit is tapped from top of the column. It is then cooled to cooler and set to the storage tank as a head and impure spirit. Alcohol content gets enriched in the top of the column and it is then tapped and cooled in the cooler, to which the storage tank is called as rectified spirit. Extra neutral alcohol. Extra neutral alcohol is collected in the bottom of the column and cooled in the cooler and sent to the receiver. Anhydrous alcohol. The water molecules can invade the inner surface of the molecular sieve, bend and be absorbed therein, while the ethanol molecules are too large and pass out of the vessel, leaving the water behind. So important parameters. So about 1% of alcohol of total production is saved by scrubbing the fermenter gas. The external aeration allows the recovery of CO2 uncontaminated with air. So these are the operational limits of fermenter. Fermenter pH is 4 to 4.8. Dissolved solids level of 12 to 16%. Fermental ethanol concentration of 6.5 to 8%. Feed of molasses and weak beer temperature of 28 to 34 degrees Celsius. Thank you.